Welcome back to my Vulcan 4x hunger run. In this episode we are going to be smelting some of our missing metals still, like lead, and if time permitting, hopefully get our current solid fuel generator set up automated with an IC chip. But as always, first thing, we're going to go mine ourselves some ores. So if you're like me and you get yourself lost in the dark and it's not morning yet and you can't see where your base is, you can just fly really high up with your jetpack, especially on Vulcan where you start with a high tier jetpack, and look around while you're high up for your base. Because when you go higher like this, sometimes you can see the sun from your current angle and it immediately causes the surrounding fog to change from black to basically the lower daytime fog where you can actually see. So even though it's not daytime yet on the ground, it could still be daytime while you're high up. And that will allow you to see your base and find your base and navigate towards it.
Temperature high.
Okay, so now I want to build myself an IC editor motherboard. So let's just search for motherboard and nothing. Right, let's go get that MK2 electronics printer mod to upgrade our electronics printer, because I have a feeling I'll have access to the more advanced stuff like motherboards if I do that. This is why I actually bought one near the beginning of this run. If you guys were paying close attention, I actually picked one up for a trader pretty early on. It saves me the trouble of having to manufacture the expensive item myself. To do the upgrade, you actually just equip the mod and use a blowtorch. As far as I'm aware, the MK2 mods don't give you all that much advantage, but they do offer a nicer interface, and they do give you access to more advanced stuff. And I still can't find my IC editor. Let me just search for it quick. That would be why I need this advanced logic systems. I always hit escape thinking it will get me out of these menus, but they don't. So let's go build ourselves a yellow research module. Oh cow, Astroloy? Are you kidding me? Astroloy? I'm not gonna set up a whole MK2 furnace and everything just to get 3 Astroloy to build one little research module. Although I don't really want to give up on my IC editor, I kind of promised it for this episode. I think the only real choice now is the trader. And here I was digging on the trader, and now I'm going to be relying on it to get what I want. Oh joy. So I've already checked. I can build IC housings and chips, it's just the damn editor that I can't build. So the plan of action here is I just need one editor motherboard. I'm never going to need more than that. So either I find a trader that sells me an IC editor motherboard, or I find me a trader that sells me a yellow research module, which I've seen traders sell red modules before, so maybe that's possible. Or I find myself a trader that will sell me a little bit of Astroloy. I only need 3 Astroloy, and then I can build myself a yellow research module to get what I want. So any of these options are viable, and I'm pretty sure I've seen a trader that sold Astroloy in the past, so that's probably also viable. I think I'm just going to do that and see which option comes up first. But first, I just want to smelt my remaining ores. I need to make some solder, which is 1 part lead to 1 part iron. So I'm just prepping an amount of lead to match the amount of iron I have, which is 35. Okay. No, wrong one. There we go, in goes the lead. I'm kind of just using the natural heat from outside to smelt it, since it has such a low melting point. There we go, it's busy smelting as the heat from outside transfers in through that open valve. There we go. Close that and we can pop in the iron. And now we can do our normal gas input, fuel it up, ignite, and there we go. Good temperatures and pressures. Release, and there's our solder. Let's do the lead next. It has a really low smelting point of 300 Kelvin. Or something like that, I forget. There we go. And then just get that last bit of copper. Also has like 600 Kelvin melting point, I think. There we go. And then the silver, which is also I think 600K. Leave that valve open so it just pops through when it's done. Cool. So before I go searching for random traders to try and find what I want, I kind of do want to just pick off some more food items from this trader, because I don't know where I'm going to see a food trader again. So let's sell what we can and try and get some remaining goodies, like definitely at least the 2 muffins. Maybe we'll try for the chips or tomato soup as well. I'll just have to see what money I can scrounge together.
Hunger critical.
So we're going to try the daring move of stealing some of our precious oxygen in order to sell to the trader, because I really do need a couple more bucks here. I definitely need to get some more of those food items out, and also I need some money for when I run into whatever it is I actually want to be buying. So just a note, you need to unscrew this thing from the container mount there in order to stick a tank in it, a canister in it. There we go. Something else I forgot to mention in one of the previous videos is that when you connect a tank to a tank connector, it not only shares its gas capacity, it also shares thermal transfer. So that tank that's connected to a pipe that's connected to the outside, even if you don't have gas in that pipe that's leading to the outside, the Vulcan atmosphere will actually heat the pipe itself up, not just the gas inside the pipe. And that pipe that's connected all the way to that tank connector and eventually your connected oxygen tank will end up actually heating up that oxygen tank. So when you do screw that thing down onto a tank connector, you better make sure that you're like me and that oxygen tank has been emptied out quite a bit first, otherwise it's going to be not much different from if you have left that oxygen tank outside in the blistering heat. So I've been through a couple of traders now, and the first thing I managed to acquire out of my wish list was the yellow research module. So now that we've bought one of those off of a trader, it was actually quite cheap, only like a dozen or $2. Now we can grab this thing and go grab our IC editor research and then build that and carry on with our process.
Health low.
When dealing with ores, you will often smelt them in smaller batches at a time, just especially if you're using a high-speed, low-fuel setup like mine. And that's okay, because ores you can split. Ingots, however, you can't split. So when you have multiple stacks of iron ingots, you don't ever want to put more than one of those stacks in one of these machines at once, because it will combine them into one stack, and when they come out again you won't be able to split them, which means you'll always be limited to only one machine with operating with one stack at a time, and that can be very frustrating and annoying. It's only quite a bit later in the game, especially if you have research turned on, that you'll be able to build a splitter that's capable of splitting those ingot stacks. So be very careful of that, and always keep your stacks separate, and don't put more than one of the same type of a stack in a machine unless you intentionally want to combine those stacks and never have them separate again. So now I'm starting with my alterations to the setup, first adding in some glass chutes over here and extending the length so that we can see what's inside the chutes, because I ultimately want to be able to throw in a dozen stacks of coal and then just leave them there and have the automation sort out the rest. So I'm busy modifying this setup over here. I'm going to move both the solid fuel generator and the battery just one further out from the wall. This is because I want to put one more vent between the solid fuel generator and the wall, or I should say one more chute, a glass chute, so that I can see right before the solid generator's input if there's any ore in that last bit of chute. This will help me determine if I need to feed more coal into the system in future or not. I'm also going to be changing the wall that chute goes into a glass wall, so I can see this clearly from inside the base. There we go, now we can see what's going on inside that glass chute at the back. So I'm going to be borrowing this computer and moving it inside for my IC editor programming. Since I couldn't find a computer option in the electronics printer, it's probably another research tech that I'm missing to be able to build one of those. So I'm just going to borrow this one, keep it inside. I'll connect it to the same data network. That way I can still use it for a trader when I swap the motherboard back to communications later on if I need to. So to program an IC chip, you need a couple of things. One is a computer with an IC editor motherboard in it. that you can write or load programs onto. The other is an IC housing to put the IC chip into, and then of course the IC chip itself. Now, interestingly, IC chips can get programmed as long as they're in a housing connected to a computer with an IC editor. They can be programmed via that computer interface. And once they're programmed, you can actually take the IC chip out of the housing and it will keep the program on that chip. You can then go put that IC chip into any housing anywhere, and it will still have that program. It communicates with different devices via the 6 screw nodes on the sides of the chip, where you can actually set for each node a D0 to D5 a different device that node represents, and you can do that once the IC chip is obviously plugged into whichever network. The program itself refers to those nodes by their number D0 to D5, so it doesn't care what you assign to those nodes, hence why you can move the IC chip around to housing somewhere else and then assign devices to those nodes, and the program will still work. You can write these IC programs on the computer live in your game, or you can write them ahead of time and paste them in. It supports copy and paste. You can save IC programs to your local game that you're playing, but you can also publish them to the Steam Workshop as well, which is pretty interesting. And a program can be loaded from or saved to any IC chip that's connected to that computer network. There are also tools online, which I will link in the description, that allow you to design IC programs outside of Stationeers and simulate their program and running of the program like every step of the way with different devices and effects and stuff. So very useful tools for running simulations like that, especially if you need to debug the program, because debugging it in-game can be a bit difficult, since the IC is just going to tell you error at line X, and it'll be a bit on the generic side, so it can be pretty hard to debug like that, since you can't see what's happening inside that program without modifying the program to hook up external LED displays and stuff to see values, and that's messy in game, especially since you only have 6 devices that can be connected to the IC in the first place, and you might be using all 6 for your program. So I'm just busy rewiring this network over here. Basically, I need to separate the power and the data of the battery. The power must still be the heavy cable running to the power controller, but the data needs to be connected to the data input of the solid fuel generator and the rest of the network, or at the very least the part that's gonna have power coming out of the power controller, not going into it, and also be connected to the IC housing for that data and programming. So I've got the housing wired up here. Let's slot the chip in there. Okay, that's fine for now. Let's turn this on and check out that IC editor. Okay, IC housing that's connected to, and edit. Now, I've created this solid fuel generator script beforehand, so I'm just going to load that up. Okay, there we go. That all looks right. D0 is battery, D1 is the generator. Just have to remember that. And the rest of the script is there. So we have IC housing selected. That's currently what my IC housing is called, which is not very good, since that can obviously lead to confusion. And that is also why earlier in this game, if you paid attention, I also bought a labeler off a trader. So I was worried that I wasn't going to be able to get to that, building one of those anytime soon, so I bought it off him. And the labeler we can use to label the IC housing so that it has a name that we can recognize easily and won't get confused with other stuff in future, not just IC housing. You can also name both the housing and the chip individually, but you do have to actually take the chip out of the housing and put it on the ground in order to name it. Now, the reason I put this housing over here by the computer and not in the original location where I do want to actually put it when it's done, which is above the window and against the roof just above the solid fuel generator, is because when you have these cheap iron walls, they're kind of not very flush with their wall frames, and when you put an IC housing down, the wall sheet actually extrudes past most of the housing, and you can't really access it. You can't put a chip inside. You usually can't access half of the screws because the wall sheet is like covering it too far. So you won't really be able to use the thing very easily in the final location I have planned for it. So we program it over here first, where I have easy access to everything and I can see, and then I'll go put it in its final location on the roof when I'm done, which will involve me temporarily removing the roof panel so that I can actually get the chip into the housing before I put the roof panel back. But at least then no final adjustments will be needed, so it should be a quick thing. Now I've mounted the housing on the roof, but you'll see I can't put the chip in there. The sheet metal is actually getting in the way. I can only see 3 out of the 6 screws. Granted, it's the screws I need to use, but still not ideal, which is why I had to program it in a different location earlier. So I'm going to have to wait till nighttime before I can remove that sheet and kind of complete that setup. You know, a lot of people are afraid of the whole IC chips and IC programming thing, and seriously, don't be. If you're okay with doing a little bit of programming, it's really not that difficult to use, and in fact they are super convenient. They're really good at performing anything from complex tasks to even simple ones. I'll give you an example. This little program I wrote now to do this job of keeping the generator going, charging the battery, those dozen or so lines of code, if I had to try and do that with the regular chips, I'd need over a dozen chips to achieve the same thing, possibly even more than that. It's ridiculous. It would take up so much space, use up so much cable, and draw an unnecessary amount of power to power all those chips compared to the, I think it's like 30 watts or something that the IC housing uses. So don't be afraid of IC chips, they are your friend. Even if you're not capable of writing the programs for them yourself, you know, you can always borrow other people's programs. I know I'll leave a link for all my programs in the descriptions of the various videos below, but there's plenty of others available on the Steam Workshop. It is truly an immensely useful thing. So definitely make the effort to get used to them. Okay, it's cool enough now to remove that panel so we can access the rest of the IC housing. Why am I... Yeah, things get in my way. Okay, put the chip in. There we go. Just double check D0 and D1. D0 is the battery, 1 is the generator. Okay. Now, as with most chip screws, you use the screwdriver to adjust them. So let's set D0 to the battery and set D1 to the generator. Okay, it's already on that. Okay, turn it on. Nothing's happening. It doesn't look like it's powered. Why is it not powered? Oh, I forgot to connect it up to the actual power line from the output there. Let's just do that quickly. And now we have an error, the orange flashing light. Error unknown at line 14. What's that about? There shouldn't be anything wrong with the script because it's one I imported and have used before. So that's strange. Line 14 is charging be equal to generator on. Why would that be a problem? The generator is definitely connected on the diode there. And those are pretty standard variables like the on state. Why would I have a problem with that line? That doesn't make sense. Yeah, there's generator. I haven't forgotten to assign it. So just so you know, when the housing is on, the green light, it means the program is successfully busy running. The orange flashing light means it's encountered an error in the program somewhere along the line, and it's obviously halted execution. If you hover over the orange flashing light, it'll tell you what that error is and where it is. Although, like I said, this can be quite difficult to debug. Also, IC chips have some serious limitations. They only allow for 128 lines of code, and when they're actively running, they'll only run the script itself will only run 2 times per second, if I remember correctly. And in addition to that, I think it will only run something like 64 lines of code that it will process in one of those ticks before it will pause and wait for the next cycle, which will be a half a second later. You can also save CPU cycles by putting in the yield keyword in a script. That will basically tell your script that you're done for now until next tick, then you can carry on running again after the yield. So I'm just investigating here, but trying out different keywords, testing that it picks up the different things like generator and on, just to try and figure out what's gone wrong over here, what it's unhappy about. Turns out I was just being an idiot. I didn't have the screw actually assigned to the generator. It was the next item generator that I was looking at. I actually hit that screw one more time to select the generator, which was a silly mistake. So now the light is green, the program is running. And in my eagerness to clean up, I severed a cable I wasn't supposed to sever. That was dumb. Okay, we're back up and running. Seal that up. Now let's actually test it. Let's dump some coal in the chute. And immediately I heard the generator turn on, which is a good sign because the battery is low, below 40%, which is the marker, the threshold I set in that script for turning the generator on. And then it should automatically shut down again the generator when the battery is above 90%. And it will basically then wait for the battery to drain until it's below 40% again and turn the generator back on and rinse and repeat. It will keep charging the battery whenever it needs a charge. The reason the script is written this way and not just whenever the battery is below 90% just start charging until it's above 90% is because that will kind of toggle the generator on and off pretty much constantly. And every time you turn that generator on, it immediately kind of consumes one fuel, or starts to consume one fuel. So if you turn it off immediately, it's still going to have consumed that one piece of coal, and that would be immensely wasteful because every time it turns on and off, flickering on and off like that to keep the battery at 90%, it would end up consuming a piece of coal each and every time really quickly. So we wrote this script to kind of just normalize that, so it'll only turn on when it's below 40%, and it'll keep charging for quite some time until it's above 90%, and that just is a lot more efficient on our coal usage. This means that I can just dump several stacks of coal into that chute over there and then just leave my power setup, and it will just keep everything running for a really long time, which is exactly what I want. I can just focus on other areas and not have to worry about my power situation. So that's all for this time. I'm not 100% sure what we're going to do quite in the next video yet, but I know it's definitely going to involve a rather sizable base expansion, this time in steel, because we are definitely going to want to start working our way towards that greenhouse. That's all for now, and I'll see you guys till next time.